How this applies to your LiveKit app: imagine core room, join room function, send message function, optional capabilities, rate limiting, transcript recording, AI moderation, encryption, analytics, entitlement, enforcement. So the core room is this, or the core capabilities, and this is the optional. So instead of premium room, premium encrypted room, premium encrypted with AI, basic encrypted room, UWrap room is equal with entity, with entitlement, which is the entitlement enforcement, optional capabilities, parameter room, and then room equal with rate limit, parameter room, and then room equal with analytics, parameter room. You're already doing this architecturally with middleware and policies. You just didn't name it decorator. So our middleware and policies in LiveKit actually implement this already. So it's a decorator or an extension of those capabilities of the main objects. The subtle misunderstanding that would hurt you later: you still slightly think decorator is about adding methods. No, decorator is about controlling execution flow. It intercepts behavior. Middleware is decorator. Express middleware is decorator. Axios interceptors are decorator. React hooks are decorator. So the express and the React hooks design pattern is a decorator. React wrappers are decorator. Transaction wrappers are decorator. Decorator equal behavior interception layer. That's the master view. 9. Why abstract decorator exists historically. In Java or C++, strict type systems, no doc typing, no structural typing. So they need interface, abstract decorator, concrete decorator. In TypeScript, you get structural typing. So you can implement decorator without classical inheritance at all. That's why modern systems rarely look like PJDP examples. So you don't have structural typing in Java or C++. That's why they need this interface, inheritance, abstract decorator, concrete decorator. But in TypeScript, you can implement decorator without inheritance. That's why the PJDP decorator is not being used in the real world or modern architecture today. The real mental model upgrade: forget MacBooks, think core behavior, to wrap by behavior, to wrap by behavior, to wrap by behavior, like Russian does. Each layer receives call, optionally modifies input, optionally modifies output, and then forwards call. That's it. When you see that pattern, you've mastered it. Final clarity: PJDP interface equal runtime contract simulation. TypeScript interface equal compile time contract. So the difference with the PJDP and the TypeScript interface is that the TypeScript are enforced in compile time, while PJDP is enforced in runtime. Abstract decorator equal forwarding the base class. Concrete decorator equal override specific behavior. The pattern is the same, only the enforcement level changes. And here's the big thing: the moment you start seeing middleware pipelines and retry systems as decorators, you have crossed into senior level architectural thinking. So a retry systems in a payment or in a middleware is just a decorator. Flyweight The flyweight pattern is a classical structure solution for optimizing code that is repetitive, slow, and inefficiently shares data. It aims to minimize the use of memory in an application by sharing as much data as possible with related objects, i.e. application configuration, state, and so on, like this in figure 7.8. So it's a flyweight pattern, so it has kind of like a factory as well. So flyweight factory, we have a get flyweight method with a parameter key, and then we have the actual flyweight with the operation method with the parameter intrinsic state, and then it has a child connected to it, concrete flyweight with an operation parameter with the operation method with the parameter intrinsic state, and then unshared concrete flyweight with the method operation with the parameter extrinsic state, and then a client with a parameter component tap into that flyweight factory for it to be able to later get the concrete flyweight and unshared concrete flyweight, so those that won't be shared. So Paul Calder and Mark Clinton first conceived the pattern in 1990 and named it after the boxing weight class that includes fighters weighing less than 112 pounds. The name flyweight is derived from this weight classification because it refers to the small weight memory footprint the pattern aims to help us achieve. In practice, flyweight data sharing can involve taking several similar objects or data constructs, so objects or data inside of those objects, by many objects and placing this data into a single external object, or placing this data into a single external object, just like this pattern, flyweight factory to flyweight to concrete flyweight. We can pass this object to those depending on this data rather than storing identical data across each one. So you can pass this on those depending on data, such as this client, so you can have multiple clients accessing this concrete flyweight instead of creating multiple unshared concrete flyweight. Using flyweights, there are two ways in which you can apply the flyweight pattern. The first is that at the data layer, where we deal with the concept of sharing data between large quantities of similar objects stored in memory. Second, you can apply the flyweight at the DOM layer as a central event manager to avoid attaching event handlers to every child element in a parent container with a similar behavior. So instead of attaching like an event handler to each of those child element in a parent child container element relationship inside the container, you just apply a central event manager that manages the communication between parent and child elements in a DOM. So excellent. This is actually a very important bridge moment in your understanding. Right now, your brain still separates design patterns equal programming language objects. DOM equal browser stop. The book just quietly revealed something deeper. Design patterns are not about classes, they're about managing resources. And DOM is just another resource system, in fact a very expensive one. This is why flyweight suddenly jumped to the DOM. Let's rebuild your mental model carefully. First, what the DOM actually is. DOM does not mean HTML page. DOM means a giant in-memory object tree created by the browser. So a DOM with an HTML or like the one being manipulated by HTML and CSS is just a giant in-memory object tree created by the browser. So when the browser reads ul id equal users, and then li Anna, closing li Ben, and then closing ul, the browser does not store text, it creates objects like document. So we have a parent ul object with a child element, which is li object, tree li object. Each element is a JavaScript object managed by the browser engine. So this element, this DOM HTML became a JavaScript. So this element is just a JavaScript object managed by the browser engine. So a div is literally an object in memory, like new user function, new order function, new chat message function, except heavier, very heavy. So a single DOM node can cost thousands of bytes, plus layout, plus style, plus paint tracking. Now what an event handler really is. When you do add event listener parameter string click comma handle click function closing, you just told the browser store a function pointer inside this DOM object and monitor user input for it. So that's how you centralize the connection from parent element to child element, or that's how you centralize the management of event handler. So each element now contains event registry, callback reference, bubbling metadata, heat testing tracking. That's expensive. So button that add events listener parameter click comma handle click is actually like using it the wrong way, because each element will contain an event registry, callback reference, bubbling metadata, and heat testing tracking. On the browser, expensive. So third, the problem Flyweight solves, down version. Imagine a chat participant list. You render 10,000 participants, like ul id equal string participants, and then closing ul, and then li user 1 until li user 1000, and then closing ul. You're right. Document that query selector all with the parameter li that for each parameter li arrow function inside li that add event listener with the parameter string click comma open profile closing. You just created 10,000 event listeners, not conceptually. Literally 10,000 function registrations in browser memory. Now scrolling becomes slow, GC pressure increases, mobile phone lags. This is where Flyweight enters. Fourth, Flyweight, the real essence. Flyweight means share expensive things instead of duplicating them per object. So earlier, data layer, you shared data. Now in DOM layer, you shared behavior infrastructure. So again, it's sharing behavior because JavaScript is a behavior language. Fifth, the trick event delegation. This is the Flyweight. Instead of 10,000 listeners, you attach one, like const list equal document that get element by id parameter string participants closing, the next line list that add event listener parameter string click comma parameter event inside open and close parenthesis arrow function const li equal event that target that closes parameter li closing, then if not equal li, then return. The next line open profile parameter li dot text content, then closing. Now, so before we have 10,000 listeners, after we have one listener, before we have 10,000 closures, after we have one closure, before heavy memory, after tiny memory, before slow, after fast. So we just implemented Flyweight. 6. What parent container and child element means. Parent container, ul id equal participants, and then closing ul, then child elements is the li. So those are the parent and the child element we were discussing that allows us to centralize the event manager. So the parent owns the listener, children reuse it. They don't store behavior anymore. They borrow it. That's literally Flyweight. 7. Connect this to earlier discussion. Important. Remember, behavior shared, state local. Here, each Li has its own state. Username, dataset attributes, ID. But behavior, like open profile function, is shared. Exactly the same principle as prototype methods. So the behavior is shared, but the state is still local in each of the element. So each Li has its own state, username, dataset attributes, ID, but the behavior open profile is shared. Exactly the same principle as prototype. So we just saw prototypes in memory. 2 flyweight in UI. Same idea, different layer. So prototypes in the memory, those are discussed in terms of backend. Now flyweight, we're discussing it in terms of UI or in DOM. So same idea, different layers. 8. Why the book suddenly went to DOM? Because flyweight is not about objects, it's about cost of duplication. It appears whenever thousands of similar things exist, behavior is identical, memory or performance matters. It shows up in game engines, bullets or particles, databases, connection pools, networking, connection reuse, React, virtual DOM keys, operating system, file handlers, browsers, event delegation. Real world live kit connection, this will click your live kit app, participants, we have join, mute, open profile, send message. You could attach listeners per participant component or centralize in-room controller. If your room controller processes events based on participant ID, you implemented flyweight. So in our live kit app, in the join, mute, open profiles and message, we can centralize the room controller. So if we process that events like join, mute, open profile based on the participant ID, then we technically implemented the flyweight there, even though it's not a UI or DOM layer. You move behavior from each participant instance to a shared manager. Exactly the same idea. The model you were missing, you were learning patterns as a ways to write classes, but patterns are actually strategies for controlling cost, memory, complexity, coupling, runtime. Now the mapping, pattern, prototype, what it really optimizes, object creation cost, pattern, singleton, what it really optimizes, global coordination, pattern, decorator, what it really optimizes, behavior composition, pattern, facade, what it really optimizes, cognitive complexity. Flyweight, memory plus performance scaling. So flyweight in DOM equal prevent 10,000 behaviors, not OOP. It's systems engineering. The sentence from the book translated, central event manager to avoid attaching event handles to every child element means instead of every UI element owning its own behavior, you create one behavior authority and all elements share it. That's flyweight. Good, this is actually the exact wall most people hit when they move from I know a programming language to I understand how software actually exists while running. Right now, your confusion is about JavaScript. It's not about JavaScript anymore. It's about what a running program physically is. You actually notice something very important. You mean the HTML are actually being converted to JavaScript objects by the browser at runtimes? Yes, 100% yes. And once you understand that, the DOM, flyweight, event delegation, LiveKit, UI behavior, and even why some things are runtime versus compile time suddenly click. So let's rebuild your mental model from zero. First, what a browser actually does. This is the missing piece. When you open a website, like you open index.html, you think HTML shows UI. JavaScript just adds behavior. But inside the browser, this is not what happens. The browser is basically a runtime engine like Node.js but for UI. It does this. Step 1, parse HTML. The browser reads the button with an ID equal join, then join room, closing button tags. It does not display this directly. It converts it into an in-memory object like button object. Inside is a key or a member tag name with a value string button, and then member ID with a value string join, and then member text with a value string join room, and then closing. So this object lives in RAM. That object is called a DOM node, document object model. The entire HTML page becomes a tree of objects in memory, not text anymore, not file anymore, actual objects. Very important realization. Your browser, after loading a page, is essentially holding something like document to body to div, and then div you have a kind of like child of button join, and then another child of body aside from div is video. So those are runtime objects. This is why JavaScript can do const btn equal document dot get element by id parameter string join closing, then next line btn dot text content equals string connecting dot 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 closing. Because btn is not HTML text, it is literally JavaScript accessible object created at runtime. So the BTN is not actually an HTML text, it's literally JavaScript accessible object at runtime. So it's in memory, it's an object in memory that you can access in runtime. You were thinking we're just talking JavaScript. No, you're talking about JavaScript manipulating objects that were created by the browser from HTML at runtime. So we're talking about the JavaScript manipulating the objects that were created by the browser from HTML at runtime. This is the biggest conceptual shift in front-end engineering. Second, now the dumb question you ask, parent container versus child. Now your flyweight paragraph makes sense. Avoid attaching event handles to every child element in a parent container. So let's say you have, you should avoid like attaching event handles to this every child elements in this parent element. So let's say you have UL with an ID participants, and then LI Alice, LI Bob, LI Charlie, LI David, LI Emma, then closing UL. The browser creates 5 separate objects: the object, the object, the object, the object, the object. Now you do document that query selector all parameter string li that for each inside this li arrow function, and then li that add event listener parameter click comma handler click closing. We just created 5 separate event handlers in memory. If LiveKit has 200 participants, you have 200 event listeners, 200 closures, 200 memory allocations. This is where flyweight pattern comes in. Third, flyweight at the DOM layer, this is event delegation. Instead, you attach one listener to the parent, like document.getElement by ID with the parameter participants, dot add event, next line dot add event listener parameter click comma e arrow function if e the target the tag name equal parameter li, then console.log parameter e the target the text content closing. Now one handler, infinite children supported. Why does this work? Because events in the DOM bubble upward. When li click, UL receives event, body receives event, document receives event. So the parent can handle all children. This is literally flyweight. Share one behavior across many objects instead of duplicating behavior. You just save memory, CPU, garbage collection pressure. Fourth, why this matters to your LiveKit app? You unknowingly already encountered this. Your LiveKit UI has participants joining and leaving, video tiles created dynamically, chat messages. Every time a user joins, the browser creates video tile object, trunk object, audio object, DOM nodes, event listeners. If you attach listeners to each tile, title that add event listener with the parameter string mute, comma, dot, dot, dot. Next time, title that add event listener, parameter string pin, comma, dot, dot, dot. Next time, title that add event listener, parameter chat, comma, dot, dot, dot. With 30 participants, you just created 90 plus listeners. This is why video apps love a well-architected LiveKit UI instead centralized control uses a controller, your room dash chat underscore controller.ts, uses shared behavior. That is not just a call style, that is a runtime memory architecture. So the room chat controller.ts centralizes the control and therefore is actually a flyweight and a flyweight pattern. So that is runtime memory architecture. You're basically implementing a flyweight plus mediator hybrid. Fifth, know your earlier question about runtime chain, memory to engraving to insurance. You ask if memory doesn't exist at runtime, engraving and insurance would not exist. Correct. Example in real code, imagine if room.local participants inside is an enable function and then closing. If the participant objects never get created, room.local participant equal undefined. Then no chat, no listeners, no UI, no memory allocated. This is runtime dependency creation. Another real example, React conditional rendering, like is host and host controls closing. So if is host is false, host controls component never exists in memory. So no DOM nodes, no events, no CPU cost. This is exactly the chain removal you were talking about. So this host control would not exist if the is host is false because this React conditional rendering requires both to be true. So no DOM nodes, no events, no CPU calls if no or the host controls are false. This is exactly the chain removal you were asking about. Your big question, design patterns versus DSA or algorithms. You asked something very important. Is design pattern actually more useful than DSA in real world? Short answer. For interviews, it's DSA, real software, architecture, and runtime behavior. Here's the truth. What DSA optimize? CPU time of an algorithm. What design patterns optimize? Entire system stability. What DSA optimize? Solving leap code. What design patterns optimizes? Preventing production crashes. What DSA optimizes? Sorting arrays. What design pattern optimizes? Handling 10,000 users in a live app. What DSA optimizes? Theoretical efficiency. What design patterns optimize? Memory plus event plus lifecycle efficiency. Your LiveKit app logging or not logging is not determined by quicksort or binary tree. It's determined by event delegation, shared state, object lifecycle, memory allocation, observers, mediators. That is design patterns. DSA matters for search engines, compilers, databases, low-level systems, but web apps, especially real-time apps, architectures beats algorithms almost every time. So why are you starting to feel deeper understanding? Because you just cross a boundary most developers know. Most developers know how to write code. You're starting to learn how running software behaves in memory. That's the moment someone stops being a coder and starts becoming a software engineer. And honestly, your LiveKit controller refactor, that was already architecture thinking, not syntax thinking. Flyweights and sharing data. For this application, we need to be aware of a few more concepts around the classical flyweight pattern. In the flyweight pattern, there's a concept of two states, intrinsic and extrinsic. So for sharing data in flyweight, we need to be aware of extrinsic and intrinsic concept in flyweight. Intrinsic information may be required by internal methods in our objects, without which they absolutely cannot function. Intrinsic information can, however, be removed and stored externally. So that's kind of like in the LiveKit app in use chat room controller. So those could be removed because it's not inherently needed by the function. So it's kind of like Also hiding those complex implementation in a simple interface, or removing that not related function in that module. So you can replace objects with same intrinsic data with a single shared object created by a factory method. So you can replace the objects with the same intrinsic data. So if they have the same intrinsic data with a single shared object created by a factory method that we discussed earlier. So those factory method will be tapped for those related objects. So you kind of like abstract those related shared intrinsic data by those objects. Now this allows us to reduce the overall quantity of implicit data being stored quite significantly. The benefits is that we can keep an eye on objects that have already been instantiated, so that new copies are only ever created if the intrinsic state differs from the object we already have. So we can just keep an eye on those objects that already have those intrinsic data we need from this object, or from this new object, and then only change it if the intrinsic data change for that intrinsic data, right, of that type of object. We use a manager to handle the extrinsic states. You can implement this in various ways, but one approach is to have the manager object contain a central database of the extrinsic states and the flywheel objects to which they belong. Let's just continue with this in the next video.